Okay, so we are going to skip number 5 because you haven't learned that yet. That's coming up pretty soon, but let's look at number 6. So you throw a dart at the board shown. Your dart is equally likely to hit any point inside the square. What's the probability it lands inside the circle? Okay, so probability is what you want over all the possibilities of what you can get. What you want is in the circle. So I'm going to draw a circle here. This helps me. Everything you can get, it says that it's definitely going to hit inside the square, right? So it's not going to hit like here. So that means all of the possibilities would be the whole square. Okay, so now we're going to use some geometry to figure this out. So the area of the circle, well, area of the circle is pi r squared. So pi r squared here, 12 squared is 144, so that would be 144 pi. And then on the bottom, I need the area of the whole square. And the formula for a square is length times width, or side squared. So 30 times 30, which gives me 900. Okay, then I'm just going to use my calculator when I go ahead and do that on my calculator, which I need to do right now. So 144 times pi divided by 900 gives me 0.50 and so on. So it's about 50, I'm going to say 50.3% if we're doing this as a percent, okay? You could leave it as a reduced fraction or a decimal, but I'm going to do this one as a percent. Now, what's the probability your dart lands in the square? So it's in here, but it's outside the circle. Well, we don't have a formula for this gray stuff, right? That's what we're doing for this problem. So if you remember back in 6th grade, you did like weird shapes, irregular shapes. And the way you did that was you took, actually we did this the other day with we've done this with polynomials as well. You take the whole square and you subtract out the circle. That's going to give us just the gray stuff. Now the total is still the same, still the whole square. So really the bottom is still 900. The top now, we said the square is 900 minus the circle. So when I go ahead and pop that into a calculator, and if you do it all in one shot, you just have to put the top in parentheses, or else it's going to think you just want to divide here, okay? But you can do the whole thing, just make sure it looks like this on your calculator. So if I type the whole thing in, and I divide, and then I turn it into a decimal, that's going to give me 49.7%. Now I want you to look at A and I want you to look at B. So I want you to look at these two answers and ask yourself, what's the relationship between the two? They add up to 100, right? So why do they add up to 100? Well, because that's all the possibilities. So the circle plus the gray stuff gives you the whole square, and the whole square represents the total possibilities, 100%. So technically you could do this one and then you could just say 100 minus this one is this one, but let's say you were taking a test or doing a problem and you only had this question, you didn't have this question. You would still need this lovely formula to solve it. But if you're given this one first and then this one, you could just do 100% minus this would give you this, okay? They're complements basically of each other. All right, let's look at this last one. The sections of a spinner are numbered 1 through 12. Each section has the same area, right? So it's not like one is more likely than the other. You spin it 180 times and the table shows the results. For which number is the experimental probability the same as the theoretical probability? Okay, so remember, theoretical probability is what should happen. So if I spin a spinner that has 12 numbers on it, each time I spin, I have a 1 out of 12 shot of getting any number. Now, if I spin it 180 times, well, then I should have a 1 out of 12 chance of getting of one time, but then I would do times 180 to see how many times should I get that number in 180 spins, right? So if this is one spin, then times that would give me 180 spins, right? So if I can do that on a calculator or I can simplify it, so 180 over 12 is going to give me 15. So technically, I should get each number 15 times. Now look, this is the experimental probability. We said that theoretical probability is just theoretical. It's what should happen, but you really need to spin that spinner like a bajillion times for this to get more accurate, right? If 180 sounds like a lot, like I don't want to sit here and spin a spinner 180 times, but in the grand scheme of life and math, 180 isn't that much. So, for some reason, the 6 only came up 8 times. Like, that happens, So let's look through here. It's asking which number did the experimental probability end up as the same as the theoretical? The theoretical is 15. So which number came up 15 times? Number 9, right? So the answer is number 9, because this is the only number that did what it was supposed to do. Good job, number 9. Okay. Some are close. This is pretty close, close. Like I said, the 6 is a little low. For some reason, the 3 came up a ton. And that happens. If I were to spin it 18,000 times, it probably would be more accurate. 18 million times, even more accurate. Okay. So for extra practice, you're going to go ahead and do the practice problems for 10.1. And please reach out if you need any help.